inspired by Pinocchio. Another example, here we have industry robots, say URL10, the same data in the console, and we have that blue green lines which represents distances from base of the robot to every robot part. Okay. On this example, I want to show you we have models in every example. One model for visualization, and this is that nice model. And the second model is model looks like ghost, and this is model for collision checking. And we do it because this model for collision checking has less triangles, so the calculations of collision can be faster. Okay, so now a couple words about motion planning. So what is motion planning? So motion planning is motion from start point to goal point, or like some people like from A point to B point. And we can expand the definition to say, for example, motion planning is going from start point to goal point with avoiding collisions, or we can add here next fancy sentences. But for us, what is important, motion planning is 4 steps. Inverse kinematics, path planning, trajectory generation, and low-level control. So the first step, inverse kinematics. What is this? It's the process of computing the joint angles needed for a robot manipulator to place its end effector at a desired position and orientation in task space. So in simple words, we know where is end effector, or we know where the end effector should be, and we need to calculate angles in our actuators. So how PyRobot deals with inverse kinematics? Here start point and goal point are random, and we can see how the robot try to adjust the goal point. It's only dummy move, so you can see sometimes it's buggy. Next step in our motion planning diagram is path planning. And path planning is a process of finding a collision-free path for a robot to move from start configuration to a goal configuration. It involves navigating through the robot's configuration space while avoiding obstacles and optimizing for criteria like path length, smoothness, or energy. And today I will talk to you about 2 motion planning methods. One of This is search-based methods, or like some people like graph-based methods, and second is sampling-based methods. And today I will focus about sampling-based methods. So the famous algorithms from this first one group is A star, B star, D star. From the second is RT and PRM, probability roadmaps. I will show you a lot of examples with these algorithms today. Okay, so some useful definitions in motion planning C. So probabilistic completeness as one as the number of samples increases. So we put more points to the our space, and the chance to finding a path increases. And the second definition, asymptotic optimality. So as the number of samples goes to infinity, the solution occurs to the optimal. And this second definition you can see in action here on this view. The red line is our path. As you can see, the number of points increases and the path going to be shorter. Okay, and two more definitions. Feasible path planning. So we say we won't find a feasible path, we want to find any path. So we don't care about time or shortness or energy use or cost. We want any path. And often, when we want to feasible path, we want our path fast. And the opposite to the feasible path planning is optimal planning. And here, we want the best path which exists in our space. Of course, according to given criteria like smoothest, shortest, minimal cost, minimal energy. Okay, the next box is trajectory generation. So it's a process of converting a geometric path into a time parameterized motion that respects velocity, acceleration, and dynamic constraints. In PyRoboplan, we have implemented two modes of trajectory generation. One of this is trapezoidal mode. So I will show you example which I recorded. So we get a lot of plots, one plot for every one joint. And here we can see position, velocity, and acceleration of each joint. And the robot will be moved according to these curves. And of course, you can see trapezoidal mode means the velocity has trapezoidal shape. Okay, the next mode is quintic mode, and I think you will spot the difference fast because we have polynomials in velocity and acceleration. And of course, the movement of a robot should be slightly different. Okay, and last part is a low-level control. So today for us is a software which changes trajectory
to some electrical impulses for a robot. Okay, now a couple words about sampling-based methods. So, what is it? Sampling-based methods based on random samples, and we put random points to our configuration space, and then we try to join them according to some rules. And what's the difference between search-based methods and sampling-based methods? In search-based methods, we need to discrete all configuration space to the grid. In sampling-based methods, we don't need to do it because we put points randomly. So it's less computational efficiency in large configuration space. Okay, now I will show you two algorithms. First is RRT, so rapidly exploring random trees, and this is how it looks in PyRoboPlan. So we have 2D space, random start point, random goal point. This pink path is of course tree, which is building by the algorithm. Okay, RRT algorithm has a couple of variants. So first variant, and I think the most important, is RRT star. And difference between classic version and star version is in star version we have something called rewiring. So when we put the next point to our space, we can change the tree. So we can spot the difference here. The lines are straight. In example before, there was has characteristical right angles. Okay. So what is rewiring? This is not PyRoboPlan. This is my old project from college times. But here will be nice to see how that rewiring looks. And on this example, I will launch the algorithm twice. First, we're looking for a path, like in the traditional way. So path was funded, and maybe some of you spot this rewiring. And in the second launch, I disabled finding goal points, so the algorithm will be building tree to infinity. So I think you will spot what is that rewiring. I recommend it to look on this space. The tree is evolve. So this long example. Okay. So the next variant of RRT algorithm is bidirectional RRT, and here the difference, we build tree from start point and from goal point. So we can join that trees and find the path faster than in a traditional RRT. Okay, and the next variant is RT Connect. So here, the difference is when we see next point, we can join them like here on that long straight lines. So we make something like shortcut. Okay, so let's move to robots. First, 2 degree of freedom robot, and this is how RT algorithm look on that robot. And of course, we try to avoid these two obstacles. Okay. This is how RT star looks on 2 degree of freedom robot. And bidirectional RT. Okay, and here I prepared nice example. The start point and goal point are the same, so we can compare how that path looks. So of course, RT star is the best. Okay, and now let's see examples on robotic arm. So everything is like before, but now we have 7D robot and path in 6D configurational space. You see, it's not easy task. Sometimes it took some of time. And you know what is next. Oh, RT star. And bidirectional RT. Oh, it's long example. Okay, so like before, everything on one picture. We can compare how it looks. Okay, bad news. There are more of variants, but the rest of them are not implemented in PyRobo plans. So, like you. But if you are curious about that, I recommended that paper. You can read more about RRT. And another famous algorithm is PRM, probabilistic road maps. And this is example from my project. I will fast show you how it works. So here, oh no. In this algorithm, we spot some amount of points to the configurator, to the space, and then we try to join them according some rules. For example, n neighborhoods or some distance rules. And I will launch here that example twice. I think the first one is n neighborhoods. So we joined the points, then we joined the points. So we have now a graph, and we run a star algorithm to find the optimal path. Optimal in this graph. It's not optimal path in this space. Sorry, I try to repair. We need to live with that. Okay, so now this time will be distance rule, and you can see the founded path will be different because it goes here. Okay, and how probabilistic roadmaps looks on 2 degree of freedom robot. Okay, and important thing, the goal point changes, but the tree or graph are the same, and this is tiny advantage of probabilistic roadmaps because it's multi-query algorithm. So when environment not changes, we can reuse that tree to find another path. And how star version looks. And in star version, that star means a distance rule, how we joined the points in the graph, and that distance is some logarithmic function. So I don't want to put that here, but you need to believe me that star version of probabilistic roadmaps gives us better path than classical version. Okay, and how it looks on robotic arm. Yes, a lot of mess, a lot of points, a lot of edges. We can see anything. Yes, but that's how it works. Okay. And star version, I decrease here a number of points, so the visibility is better. Okay, and here algorithm can't find a path, so put more points, and again we can't see anything. Okay, so let's go forward. Okay, now Cartesian path planning topic. So in Cartesian path planning, we will focus on task space. So we want to control end effector, and here we want to plan straight paths, and it's needed in tasks like welding, painting, some inspection or assembly. So examples. And here PyRoboPlan gives us a nice plot how every angle of every joint will change in time. Okay, another example, but more fancy path. You can see, of course, the angles are different. Okay, and next topic, optimizations. So we have a couple of optimization things in PyRoboPlan. One of them is trajectory optimization. So we can, thanks to optimizations, we can plan smoother paths. Okay, and for that example is for optimization there are using cubic polynomials. Okay. Okay. We can optimize paths too, and here I have example with RRT path optimization, and for that is used cubic trajectory optimization planner, and here is RRT star algorithm, so planet path is good, but when we see carefully, we can spot that there are two of that paths with axes. And of course, that red spheres, they are for collision checking, so it's another feature in PyRoboPlan. And here the path, you can see that path is different. Okay, another optimization. Here is classical RT path, so it's quite bad, and here we make shortcuts. So if we can see from one point another point, we made shortcuts. So you can see here the path is much smoother. Okay, and next thing, in PyRoboplan, we have implemented TOPRA, and TOPRA is time optimal path parameterization via reachability analysis, and it's implemented in a Cartesian path planning example. And we can see that curves are much smoother than before. And sorry, yeah, okay. So here we can compare a path created by PyRoboplan and a path optimized by TOPRA, and the path looks like a cube. And here, of course, the curves are much smoother, and I don't remember which constraints I put to that algorithm, but the time is much lower than for the path made by PyRoboplan. So at the end, I want to show you two nice features. One of them is cloud avoidance. So we can put point cloud to the PyRoboplan, and robot will be avoid them. Okay, and the last example, collision along path. So maybe it's obvious, but if you collide with something, robot will tell you about that and will tell you which part made collision. So this is the end of my presentation. This is sources which I used to prepare that presentation. I recommend that repository and invite you to check it for your own. So thank you.
Okay, thanks, Maciej, for the presentation. Any questions to our speaker? Okay,
Okay, so my question is, because in a lot of videos in your presentation, there were points chosen, and could you please tell us what was the condition on which the points were chosen? Were there random points between which the path was planned, or were they picked by you?
But start and goal point?
Yes.
They are random.
Okay, because one thing puzzling me, the video with the point cloud, the start and stop points were quite next to each other.
Aha, okay,
And
maybe
the robot
in
arm was going through a lot of unnecessary area to reach from one point to another.
Okay, maybe in point cloud, because I made that example in different times, and maybe I put but here,
A little later on.
Later here.
Yes, most probably, yes.
Okay, so because robot need to, maybe the configuration is different, so need to change.
Okay,
You
so
see, because green axis is here and here is here, so robot need to replan. So
okay, so
maybe this is the reason.
it was not only the purpose for robot to move from one point to another, but also land here with a proper orientation.
Yes, that's
okay.
why it's not easy.
Okay.
Okay, so all those path planning and collision avoidance are done on the CPU. Did you experience with maybe trying to find a way to utilize like GPU and like some parallelization with the algorithms?
No, I am only user and tiny contributor in this project. But I think it's a good idea. If you want, contributors are welcome. So I think maybe it's a good idea.
Sure. Yeah, anyone is welcome to make open source contributions. We highly encourage that. And another question that I have is that, did you have an example where the point that the robot is trying to reach is moving through the space? So the robot would be following it, maybe for example with lower velocity, but the planning would have to run online.
No.
But which algorithm would you pick if you had to like develop an application for that?
RT star maybe.
And I've seen that this is mostly like based on the Cracow robot. So did you have a chance to implement and test it out in real life with a real robot?
Yes, it's because it's based on URDF, so you can put every robot if you have, of course, data and you adjust code to these examples. But it's.
So, for example, with the one on the desk, if you had like the same model, let's say.
Yes, of course, it's possible, but I think you need to put a lot of work to prepare that.
Okay.
Okay, so there is a variety of motion planning libraries available to choose from if you want to like build a solution. So I think the most used one is OMPL, as it's used in MoveIt like library. So like my question is the advantage of the one you're presenting that you can test a variety of like algorithms for the planning, or are there some other like highlights or advantages to use this one over the others?
Okay, I don't think anyone wants to achieve something big by this project. It's for educational purpose, so it's only demonstration.
Okay, thank you.
Alrighty, thank you for your presentation. I have a question regarding all of these methods. You talk very much about the computation and that we need to find some trajectory through the space. Is there any way to reuse already pre-computed trajectories in future? Some of these things doesn't change from time to time, so probably it's possible to reuse a part of that calculations.
Yes, and I agree, but theory and in college, a professor told me that RT is single query, so you can't reuse it. But I think in practice it's possible if environment not change.
Okay, thank you. And I have a second question. There was a lot of variants about random trees in path planning. What about other bio-inspired methods, maybe searching something related to ant algorithm or maybe bees algorithm?
They are not implemented. So
All right.
so if you have free time.
I see. Okay, thank you very much.
One last question, like, because I wanted to ask about what hardware was this tested on? Is it like a normal PC laptop, for example, or?
Yes, you can run it on your laptop.
Yeah, but like some examples, for example, we've seen it took like 10 seconds or something. So this is like because it's single-threaded, or? I mean, it's Python.
Yes,
so
I think it's single-threaded, and it's in Python. So you know, Python, it's not really fast.
And the other thing, this is the last question, I promise. So those path planning algorithms are also used, for example, in computer games. So did you also research like the current, let's say, state-of-the-art algorithms that are in the computer games, or check how they look like compared to robotics?
No.
Okay.
No.
Okay. So yeah, it's 8 p.m. Anyone has more questions? If not, then thank you for the presentation again. It's not easy as it looks, so yeah. So now we welcome you to a 15 minutes break for networking and beer. So yeah, see you.
Work in Hubraum, the place where you are. I'm not quite sure how much you know about us, so just 3 sentences. I have to say it, but maybe in the future our paths will cross again. So Hubraum is the technical accelerator of Deutsche Telekom. Of course, here in Poland, we work under umbrella of T-Mobile, but basically we get our work and we have our cooperation with Deutsche Telekom. So as you can understand, it's a huge corporation, and our business here, our task here is to look for startups who would like to first test their technology. For example, here in this very location, we have the test bed for 5G. So whoever is thinking or has an idea of using 5G in some way, we can test this idea. We can try how it works and whether it's going to work better with our 5G or not. And the second thing is we are also this kind of organization that is a small, agile group of people who are better, I think, fitted for connecting small businesses, startups with huge corporations. So if you would like to understand better, or if you'd like to see how to talk to huge corporation, we are the place to start this conversation, all right? I hope again that this is not the last time you're here, maybe the first time for many of you, but I hope not the last time. And since you already are holding beers in your hands, I invite you for the networking, and I guess this is the rest of your agenda, right? Am I correct? So thank you again, and have some fun.
about AI agents in ROS2. So please give him a welcome.
Well, welcome and thank you all for coming tonight. I want to talk about tool that we have developed at a company I co-founded. Okay. Okay, so welcome everybody. Thank you for coming. Tonight I want to talk about tool that we have built in company I have co-founded. The company is called Wise Vision, and we did MCP server too. But first, start why bridge AI and robotics. Let me ask you a question. How many of you are using VS Code Copilot? Raise your hand. GitHub Copilot, yeah. And how many is using Cursor? Way less. Okay, so all of you know how the Copilot can accelerate code development, unit tests, and also finding corner cases. But it can do way more. Last update that was big enough, it received own video series about was agent update. It was a couple months ago, and it adds different approach to code editing and also the code-related stuff. But focusing about ROS2. ROS2 in robotics is nervous system. Basically, what it can do is communicate either with different machines or at local host. It's super efficient about this, and also can support a lot of devices. It's quite powerful, and up to 2030, it's supposed to be included in almost half of the robots released public. LLMs, on the other hand, works as a brain and language. It's I'm not asking even how many of you are using ChatGPT, because I'm assuming all of you. Then you certainly know that you can do typos, write in mixed languages, do whatever dirty you want to post it, and it will produce some output. In most cases, it's quite good, but always there is. So our goal was to write a tool that can speed up code writing, especially the part where we're testing it, where the user needs to write unit tests or AI is writing, but we need a stable way to check whether our nodes were publishing and receiving exactly what we wanted. We will come back to this later, but first let's talk about what's Model Context Protocol. Let me ask another question. How many of you know what's Model Context Protocol, MCP? Yeah, superb. So for those who don't know, the MCP is a JSON-style format of providing context to LLMs. It defines tools, that can be used, and it's often considered as a USB-C for AI. USB-C because you can connect a lot of things into LLMs and solve one big problem, the hallucination. The MCP provides exact path for the LLMs to go to access what? Data. The MCP is for accessing databases mostly, but that was the purpose, to provide some stable way, for example, to Gmail and Slack and whatever. But the difference between using MCP and sharing raw API is a layer of, let's say, privacy, something that you can limit the agent, limit access of the agent. For example, if you're writing an email, you don't want the agent to allow him to delete some other emails. Let's say you want him to give access to writing a draft, and then you will send it manually. That was one of the reasons this tool came alive, and it was made by Anthropic and published at the fall of last year. Currently, it's supported by major companies, OpenAI, Google. I'm not sure if it's already supported, but it was publicly released that it will be supported in Gemini. Claude, of course, because they did that. Yeah. So how the MCP works inside? Yeah, there is a runtime loop that provides a context for the agent. The difference between providing a context manually and via MCP is that it can access what he basically know, and you don't have to write at the beginning or at the end of your prompt the context, like you are something, do this and that, and also this is the schema of my CSV. Please write some code that will analyze it. You can directly provide access to the database, so the agent will call when needed and get information of the structure of the database, get specific fields, put some data into the files. It can do basically anything it will be provided to. Yeah, that's the thing. And also, it's on the fly. It's not static. It's dynamic and can change at every prompt, and the agent will get that. So what we did was Python plus RCLPy node, and we treated ROS2 as a database. It might sound a little off, but if you consider this for a while, ROS2 is a system of exchanging messages and can be considered as a living database without a history. Something, this was the approach we taken. Yeah, that was the idea. And we're going into spin up. It's super easy to start working with this. There is currently around 10,000 MCP servers available online for different purposes, for connecting agents to Canva, to PowerPoint, etc. And this is the configuration. Basically, that's the only lines you need to put into VS Code to start using our tool. Yeah, it can run in any environment that supports MCP, so VS Code, Warp, a lot of them. Yeah, and the thing I was talking briefly, what speed up code writing. I was wondering about the title of this presentation and seen catchy phrase posted on AdLink LinkedIn. It was called "How We Accidentally Built the Fastest ARM Computer," and I was wondering whether we should do something like "How We Accidentally Built a Tool That Connects" instead of writing code. But that was the idea behind this project. This was the starting point. Using MCP help us write better code. We came into a problem of writing a controller for a robot, like controlling wheels. We published some velocity. We're checking how far it goes, how far it went, and comparing results versus what we have in the data. But fine-tuning controllers, it's usually hard and requires a lot of iterations. So we decided to write a tool that will basically fine-tune the controllers automatically in one-shot loop of code generation. The way it was supposed to work was AI agent is writing the code. Later, it's checking, auto fixing. And at the step of unit tests, we were using MCP to force agent to publish some ROS2 data, and also at the output of our node that the agent was writing, get the result and only accept when the results were close enough. And it's working. This was super surprising, but it was working. There is a point, support all possible ROS2 types. There are few implementations of MCP ROS2, but they're starting from different point. They're focusing on one task, like for example, publish CMD_vil or twist command to control the robot, get data from camera. We started from the unit tests, so our assumption was that we have to support all the possible types in ROS2. No matter if you are using STD message or your custom one, you want to use it without writing new tools for your MCP. And that's what's the difference between our solution than other available in market. And here is a short demo of twist control. The command, it's pretty simple. Go up and then forward. For human, this might be easy task, but for AI, it's kind of complex. You can see that it's using some tools, but basically LLM has to decide about the values of the robot speed, and yeah, anything. We just said go up and forward, and the rest is in hand of Claude 4 in this case. Yeah, that was the first demo. And the second one is, have you heard about Ukrainian spider web operation? Yeah, so this was a drone attack from trucks, and the drones were controlled by operators, UAV. We tried to mimic that with our tool, yeah, and these are the results. This is the first command for the AI, so clear cache, clear everything, and the task was to, yeah, it was on purpose written half in Polish with some typos, etc. The goal was to understand about the ROS2 system, what topics it has, what services it has, and what can be done. Also to get image from the camera and tell what's in the simulation in this case. So here is output of the cloud. Yeah, to me it was mind-blowing that out of the box it said that it's possibly O3DE based simulation, and it truly is based on service names, yeah, probably, but it was shocking to me. Also, there is information that it has seen some aircraft. On the next prompt, there was even more simple task. The task was to fly in plane direction. Yeah, we can see how it went. So. Yeah, for those who don't see exactly what's on the screen, the drone was flying forward and right with angular velocity. It said that it's above the aircraft, way closer, that it's possibly military aircraft with folded wings, 2 engines, air intakes, etc. Yeah, we all know that LLMs are super effective in image processing, but that's the way you can do it with your robots out of the box. Yeah, just out of the box, it's working. Yeah, and here is a screenshot of the output. Yeah, you can see it's the AI. It's understanding what's the plane, what's the direction of the plane. It's super simple for human to understand what does it mean to go into some direction, but for LLM, it needs to get relative position to this object, understand whether it's above it, etc. That's a long chain of thoughts needed to at the end publish at the exact topic. If you haven't noticed, the LLM at no point was given information that it was supposed to use baselink CMDVL topic. It was only information that the drone lies in baselink namespace. So it has inferred it's on its own. The same about the camera. There was no information which topic was supposed to be used. And also on the previous screen, there was information about other possible sensors like IMU, point cloud from LiDAR, and GNSS. So in terms of performance and latency, the current bottleneck is LLM time to compute the output. The MCP works very fast as it's only a bridge or translation layer to LLMs. Yeah, and everything works localhost. The bottleneck is time for the LLMs to compute the output. For us, it's we need to wait for better models or find some good opportunity. About the roadmap, it's the tool. It's still beta, let's say. It's publicly available. There will be a QR code later, but still has some issues. It's not always working as was supposed to be. So far, doesn't provide actions, and we sometimes have issues with quality of service. In ROS 2, there is a so-called quality of service defining whether messages are transported TCP-like or UDP-like. And another big issue is parallel command execution. As you have seen, the commands were executed one by one. And one last big point of our roadmap is community testers. So it's your time to go. Yeah. So how to contribute? This is the QR code to our repo. If you want to use it, test it, publish a pull request, that's highly appreciated. Yeah, and at the end, some takeaways. So MCP is USB-C for agents. That's the one takeaway I want you to remember. And it can work with any agents that support it. So no matter whether you are using OpenAI, Gemini, I'm using it on VS Code and tested that with Gemini 2.5. This Claude is my favorite one, so that the most of it. But also GPT 4.0. Yeah. There is one limitation because MCP doesn't give the agents a lot of IQ. Exactly, to be exact, it doesn't improve their reasons to work effectively. I mean, if you are using a cheaper model, the results will be slightly worse. The better results are with better LLMs. So that's why I'm trying to persuade you. If you are using this, try first with the best possible LLMs you can access, because the results will be the best. And if there are any questions, I'm open to hear them and respond.
Okay, anyone has questions?
I used some services that provide very fast inference, like a Grok, and also I think Mistral has very fast inference on their servers. Have you tried using Grok, for example?
So far, we haven't tried using Grok, but maybe that's a good point.
And I mean Grok with Q,
Yeah.
not K. There's a difference, right?
Okay, we need to check whether Grok is compatible with MCP. That's the first limitation, but if it's faster, then it's beneficial for us.
Incredibly fast. I mean, 4.0 is like 100 tokens per second, maybe, and some models on Grok are like 500, 600 tokens per second. It's basically instantaneous, like that. You know?
Yeah, I get this. We have tried with ChatGPT 4.1, which is faster and more lightweight, but the results were not competitive to, for example, Claude in terms of reasoning what the model was supposed to do.
I'm not sure if it helps with the volume, but maybe on the stream it's more visible. Okay, so for example, did you try to have an example, like say a simulated robot, and let's say you give him a task of, okay, survive in this world, learn and adapt, and try to communicate with others and try to help them and make a world a better place or something like that?
No, but it's a cool idea to try this. I don't know if there is a timeout on the most of the agents waiting for response, but maybe there is something that doesn't have this. So.
And do you think this sort of approach could be used, for example, to create some sort of like use the LLMs to create like a memory for a robot, so he could acquire the data from the topics and, for example, yeah, let's say by analyzing the images, and then let's say there is another, maybe not a thread, but like an additional command, okay, save this data as compact possible way so that I can reference it for further use.
Let me respond to this question a little different. So we had this problem and we have a solution for that. The version 1, it's currently on our company repository publicly available. The version 2, it's going to be released any day soon. And the solution for that was to use Influx database. I was wondering whether to add the information about this, because the MCP already supports this integration. The MCP, it's a replacement of ROS2bug. The difference is that it can allows you to record the data and at the same time read it, compared to ROS2bug, where you have to select topics, start recording, then finish recording. Later you can play. In Influx, you can at the same time, so lifelong logging, so-called, but yes, we have solution for this, and it's publicly available, so feel free to use.
And while testing this, you showed like the successful examples, but did you have like an example where like the chat or the robot or the agent said, no, I don't want to?
No, we didn't have such an examples, but sometimes we have some. I don't know what's the reason of this, but when I said, for example, to drone land at something, it started landing right away without previously going on top of some, let's say, table. It landed right where it was at the start. So yeah, it's not the perfect solution, and many relies on the model, which one you're using.
So there are two experiments with LLM running a vending machine. And the purpose of these experiments is to see what happens if LLM run for a long time and start accumulating a lot of information and their context gets full, and what kind of mistakes are they going to make. So one of the vending machines operator tried to call the FBI because he was not happy with the results of his profitability of his business. And the other one became convinced that he's a human and told the team that he is waiting in the lobby and he wears a blue jacket. Because after a long time, if you run for days and weeks, it's not very tested behavior. So how long have you tried to run your robots, and did you see any special strange behavior that after a while they do very unpredictable things?
So we haven't tried this way because what we are talking about, it's days of operation. So far we are limited to commands as you have seen in Visual Studio Code, and they execute. To execute another one, we need to publish it. Yeah. Type. What else do we need? Maybe there are some scenarios it can run for hours without. Yeah, but the point is we haven't tried that. The only observation we got was the more info about the system it has, the better it works. Like it understands that topics with certain namespace are coming from robot A, from robot B, etc. But we haven't observed some, let's say, strange behaviors. It didn't try to escape the simulation or something. Yeah.
Hello, thank you for your presentation. I have a question regarding a scenario where there are more than one robot, and was there any experiment to cooperate between more than one robot?
So in this example, on the background, there were running other robots. That was the reason of providing the namespace. But we haven't done the cooperation things.
Okay, it will be very interesting to see how these robots will communicate with each other to transfer some information, observation, or information about failure of success of their task.
Yeah, think of this agent integration like a big brain above the ROS system. It's not bounded to each robot. It's rather something beyond that. It can access basically if the robots are having odometry sensor, any single one, and then based off of some reasoning, get something useful hopefully about this. But yeah, that's another cool idea to try it.
Okay, as far as I understand, a very catchy phrase for dummy robotics that it isn't an physical embodied AI, but it's just a layer above to access all data from all the robots.
Yeah, that's the thing. I've seen Robotic AI is doing project of long chain of thoughts for the robots. It's, let's say, something that was thought to be super efficient. It's better in some cases, like being accurate, but this way it's, as you said, something beyond, and yeah, really connects into one system with AI supervisor. That's the way we are looking at this.
Alrighty, thank you very much. Anybody else?
Now, okay, 3, 2, 1. Okay, so thank you once again for the presentation.
Thank you.
Now we would like to invite you for another short break, and after that there will be still lightning talks, so please stay if you want to hear more about robotics. So yeah.
Thank you
Please.
very much.
everyone. My name is Mateusz Sadowski, and I've been playing a little bit with Lerobot and SO100 ARM that you can see here. And I wanted to tell you a little bit about this. So about me, I'm a developer relations at Foxglove. I also run weekly robotics newsletter, and for the past 7 years before joining Foxglove, I've been working as a robotics consultant. So Lerobot contains models, data sets, and tools for end-to-end learning for robots. So highly recommend checking it out. Now, SO100 is the ARM that you can see. It's 3D printable. It's about $15 US per servo, so quite okay for a robot ARM. If you want to do this and do it properly, buy 2, because you should use one to teleoperate the other one. And I didn't do that, so that's why you see only one ARM here. So when I was playing with this, I dig a little bit into Lerobot API. Turns out you can use Python to connect to the ARM, stream camera data, get observations, and so on. And on the other side of this equation is Foxglove SDK. With the SDK, we can stream any robot data without ROS, and just to show it online. So here's a little bit of a demo of this. You can see the model of the robot on the top. So this works. Oh yeah, sorry. So as I move the robot, you can see it reacting. We are streaming camera, we can stream some data. And as a demonstrator, what I did here is a bit of, and this is actually 2 lines of code in Lerobot, just to get the observations. So I will record the state of the robot, just move it a little bit. And then I can stop it, and I can replay this. So it's not super magical, but yeah, I found it quite fun to play with. So if you get the chance, I recommend giving this a shot. It's a nice combination. And yeah, that's it from my lightning talk. Thank you. And if you follow Foxglove, we are starting an ambassador program, so check it out if you are interested.
Thanks. So any question to Mateusz? No? Okay.
How did you get positions from the servo? Because
so the position, yeah, I just read the.
If you move the robot by hand, how did you get a position from the servo?
Yeah, the Lerobot is constantly reading the position data from the servos, and here the torque is not engaged, so that's why I can move them by hand.
Yes, but the servo has some communication protocol or some output?
Yeah, it's constantly outputting data.
Oh, okay. Thank you.
Yeah. So
and
encoders, you read them real time.
For $15, something like that, yes?
Yeah, $15 for one, plus some import charges and taxes and whatever they throw at you.
Thank you.
It depends how much you value your time, really, because it takes quite a while to put it together. But it should be about $100 for servos, and then it really depends how cheaply you can print stuff. Yeah.
Do you need to buy that?
Sorry, again?
Do you need to buy that?
Yeah. You need to perform calibration. So it's to calibrate it, you move it to a known position. So in the docs, you will find it. I think it's something like that. And then you run the script, and it will ask you to move to all the end positions of the robot. It will take the maximum and minimum value and the starting value, and it will figure out. That's why we can just reliably create this URDF representation of the robot. I came here because I play with robots, but the what company does is this observation stack for the robots. So what you see here is what we do, basically. So we have this SDK that allows you to stream the data and this platform to visualize it.
I want to ask different questions. Thank you for coming here. I'm following your career for a long time, and yeah, super nice to meet you finally. And the question is about Foxglove. Since you started working there quite a few weeks ago, maybe there is a chance you know what's incoming and the reason behind making it closed source. What are the biggest improvements we're gonna get?
I think. So I wasn't. I joined the company 1 month ago, so I won't tell you the whole story why the change. My guess would be that companies need to make money, really, and it's hard to make money when you are open source. As for improvements, I think I've heard someone saying that the current state of the version you get online is much better than what you can get for free if you find some fork or something. Because it's been lots of improvements in stability, in performance, and so on.
Okay, I think that's all. Please give an applause once again. And we have last one talk. Mikhail, can go. This time from quite different areas, but I think that it'll be quite interesting also. Teraz spoko opcja. LLM w project managementie teraz fajną opcją. Bo jednak...
Ready? Perfect. Yes, thank you. I have a non-technical topic here because I loved, as a child, programming computers, but then sometime in my life something went wrong. And then I joined the dark side of the people who do the business things. And later I became a startup founder and a project manager. And there was a time when I had to manage many projects at once. So I decided to use LLM to help me with that. And this is a very quick lightning demo of 3 things that I'd like to show you that might be helpful for you, especially if you're developers in companies and maybe you are not very happy with your projects, with your project management, how things are going, how the processes are, it's all very draining on you. And I can tell you with project managers it's the same. So if I'm managing like 5 projects, I'm overwhelmed with a lot of information. It's really hard. My product owners do not fully understand what they need. They don't know what they want. But the developers need very precise explanations what needs to be done. And often I am in between. I don't have business analysts. And users constantly give feedback and the hypothesis that you made, what's going to work for users, are crushed all the time because they tell you what you invested 1,000 person hours in, we don't need this, and it doesn't work. And then users tell you we need something completely different, so it's really hard. So I have this idea how to make LLM assistants to project managers, but also other project team members. Nowadays, you can have your project management software easily connected to LLM via MCP. We had MCP demo just before. You can connect Jira and Claude, for example, and the LLM can help you with small and big tasks on your project, whether you're a project manager or a developer. So I have 3 very small case studies just to inspire you. Case study number 1 is write a Jira ticket or Jira tickets from a call transcript. So nobody wants to write Jira tickets. It's very annoying, but it must be done. So I had a call here on Microsoft Teams with my CTO, who is also my brother, and it's a 1-hour call, and you can download the transcript. It's very easy, and then you create in your Jira, you create a project. In your Claude, in your LLM, you create a project and you give context. What is the company? What is the company trying to build? You upload some presentations that it understands where it is, and then you just ask, and then you just give the whole call transcript over there, and then you just ask. They say, here's my transcript. Search my Gmail. It's also connected to my email for recent emails with this client. From the transcript, from the emails, from the presentation, create a list of user stories that we need to add to the backlog. And then it starts searching my emails, searching emails, and reading the transcript, and then it creates the user stories, 1, 2, 3, 4, a lot, because this wasn't 1-hour call. So we have here 12, 13, 14 user stories, and if I want, I can tell him now to save it just like that into Jira because it's connected. So it will create 14 tickets, and I have saved myself like the most annoying work that you can imagine. That was use case number 1. Use case number 2, analyze team members' contribution. So I have here 2 projects that I'm working on for a client, 2 different projects. One project in Jira here has 89 open work items. That's now how you call tickets or issues now. It's now work items. And the second project has like about 20. And I just made a test here. It was for the first time. I told him, check Jira, which project team members contribute the most. Because I don't know if you heard about this guy on Twitter. He got hired by 10 startups at the same time, and he never contributed anything. So to find these people, you can ask your LLM to check your Jira. So I just executed when I was sitting there because it takes some time. It analyzes all your projects, all your issues, and it doesn't know anything about the people, but it understands, it's very smart, it understands that I'm the best, and that I created 9 issues, and that I'm the primary project driver, and I also handle technical tasks. It understands that this guy is helping with the website, and it understands that my brother is the primary implementer, executor, focused on technical delivery, and there are also people who give feedback, like business role, occasional contributor will process feedback, and then there are patterns. What are these people doing in the project? How do they contribute? And case study number 2. So I have these 2 projects, one with 90 tasks, one with 25 tasks. One is about Salesforce, one is about the website. But is anybody thinking about the connection of the 2, or are people like always in their silos? So let's ask the LLM, check the 2 projects and give it like a super broad task. Try to identify new ideas how to better connect the 2 projects with better value for the company clients. It knows something about the company from the knowledge base. Write a draft Jira ticket description for a user story that will implement a real client benefit utilizing both projects. So if you have a meeting coming up, you have a backlog refinement meeting, you don't know what to bring to the meeting, you ask it this, and it found something. I just did it here, and it found something really nice what to do. It said, we need to do automated lead capture and follow-up integration between website and Salesforce, and that's actually not a bad idea. That's it. Thank you.
Hi, thanks for the presentation, first of all. But I wanted to ask, like, how good are those tickets are? Because, like, it's great to have like 12 tickets from the transcript, but how good they are?
So 50% are very bad, and 50% are good, and you need to be a good project manager to understand this. But if you have an assistant, it's the same. So I don't know how many of you were working with very junior people, and if you delegate, a person brings you something back, it's your job to understand, to find the big mistakes, right? So it's exactly the same here. It can only replace the assistant, it not can replace me as the project manager.
So you're seeing additional value of that. I mean, because sometimes it, like, this reviewing part can be even more annoying than the doing part.
It depends how much you're used to delegating. If you used to have an assistant, like I have an assistant call every day at 9 a.m. for half an hour. So it's like just the reality of my life is delegating. And if you train this, then getting output, which is 50% garbage, will be just your reality. But if you get it in 10 seconds instead of in 10 days, it's a huge improvement for me.
Okay, cool. And the second question would be, how about IP? I mean, intellectual property? Because you are, how Cloud like handles it? Like, because you are giving your, I don't know, transcripts, you're giving your ideas, your intellectual property to the third-party company. So if you're a startup, I don't know, maybe if it's on the very beginning, it's okay because you are not, like, you don't have anything to lose. But if it's, let's say, the corporation which has the code base for, I don't know, million plus lines of code, like, you know, spend million hours of development, how comfortable you will feel to, you know, to give this intellectual property to the cloud or whatever else LLM?
Well, in my company, it's easy because I'm the owner, so I just take the risk and that's it. I don't need to ask anybody. But in the other companies, what you need is for your IT department to install a compliance solution that will check all the compliance check boxes, and then to run all of this not on a normal account, but on the accounts that are in the company, and often they run on the servers, right? Mm-hmm. Often there is even no outwards connection from the LLM to some third parties.
Okay, because I saw that, like, the Microsoft Azure provides the services, so you can run your own infrastructure, so you can have the closed, like, intranet system, which, like, has the firewalls, so, like, no data leakage. But I'm not sure about cloud, how it's done, if it's possible to.
Well, so in this case, I have not connected the code base, but of course, all of you who are working with Copilot and Cursor, you know that that's the same thing there, right? So if your department gives you a compliance solution and allows you to do it, use it, and if not, use it at your own risk. But as a startup owner, my company is full of risk, so I'm willing to take another one. It doesn't matter.
Okay, see, thank you.
Okay, thanks. Are there any more questions? Yep.
Is this Jira integration something out of the box in cloud, or is this some custom extension? Or?
It was added out of the box just a couple weeks ago, maybe 1 week, or I don't know, 2 weeks.
Okay, yeah, cool.
So MCP was added to Cloud in November, and I spent like a whole night trying to set it up. And then I said in November on a podcast, it's going to be huge. And it's maybe stupid to spend so much time doing it yourself, because one day it's going to be everywhere. All of your tools will be connected by the LLM, everything. It's just the start.
Yeah, it's changing like week by week, right?
Okay. I don't see any more questions. Okay, so thanks. Very nice lightning talk. I didn't know that Jira is connected to Cloud.
Yeah, thank you.
Okay, so that's all for today. Of course, the networking is still open, so There are still some bottles of beer, so if you want, go there and grab and talk with each other. Thanks a lot, and see you on the next event.
Mam pytanie, czy podcast wspiera w końcu Photobacha jako produktu wiadomości?
Tak.
Tak w pełni? Można normalnie